In this tutorial, you'll learn how to solve the problems on homework number 3 on Delta Math. So let's take a look. The first one is fractional linear equations. Now you can certainly complete this problem by multiplying by fractions all you want, but I want to review with you one of the techniques that we learned about clearing the fractions from the equation in the first place. So let's take a look at our right-hand side of the equation. We actually have one quantity here, 8x plus 24, and it's being multiplied by the fraction 1/6. Now we certainly could multiply here, but this will result still in a fraction. So what I'm going to do is I'm going to take this entire side and multiply it by 6, and this entire side and multiply it by 6, because that's a property of equality. And when I do that on the left-hand side, I get a 42. But on the right-hand side, since I have this one term here with these two factors, then this 6 times this 1/6 will cancel each other out, resulting in a 1. So that's 1 times the quantity 8x plus 24, and 1 times anything is itself. So now I have an equation without a fraction. Use my inverse operations, and then I can finish this question here. So that was 3 and 8. Is that right? And then we divide by 8. And we are going to get x is equal to 9/4. And it does say simplest form. It doesn't say to convert it to a decimal. Solve for x in simplest form. So 9/4 would be our solution here. So let's take a look. 9 fraction bar 4. All right. Let's take a look at one more question. 11 is equal to 2/3 times the quantity 8x plus 12. Again, I'm going to use the same technique as I did the last time. And I'm going to multiply both sides. And what I want to multiply by is the reciprocal of that fraction. Because if I multiply by 3/2, then that will result in a 1. So I'm going to get 33/2 on this side, and the quantity 8x plus 12 on that side. Now I can do this again if I want. So I don't mind having a fraction over here on the left, but if I don't want a fraction on the left, I can multiply everybody on the left and everybody on the right by 2, and that will give me a 33 equals 16x plus 24. And then I use my inverse operations. Uh, 679. Divide both sides by 16. And again, write my answer in simplest form, which is 9/16. So let's go back and type that in and see how we did. All right. So this is a simple distribution problem here, and you can multiply by the reciprocal to clear the fraction, and maybe you want to do it more than once. All right, let's take a look at a question that's a little bit harder. Again, same technique, but this time we have more than one fraction. So pay attention carefully to which fractions I'm taking a look at here. So let's see. This is a term. This is a term. This is a term. And this one has a denominator of 4, of 2, and 2. So I'm looking at all of those denominators, and the least common multiple is 4. So I'm going to multiply this entire side, or each term, right? Remember, that's a whole term, by 4. And that's going to give me here 5x. And this one is going to reduce to 2, which is going to give me a 6. And the quantity remains. And this one is going to give me a 4 on the outside, because you don't multiply anything inside the quantity. So I know I haven't completely cleared this fraction over here, but upon my next move, I'm going to get no fraction. Negative 12 over 2 is negative 6. So I have successfully cleared all the fractions. Now I'm going to combine like terms. And then I'm going to use an inverse operation. I'm going to add 32 to both sides, because I like to keep my variable positive. Let's see, what do I get here? That's 5, 6, 7. And then over here I get negative 6. So add 30 to both sides. And it looks like I'm going to get 7x equals 24. So I'm going to move up here. And I'm going to use my multiplicative inverse here. And it looks like my answer is going to be 24/7. Let's take a look. 24/7. All right. Again, you don't have to clear the fractions. You can certainly manipulate this entire sentence by keeping the fractions where they are, which isn't such a bad idea. Let's take a look at this one here. Solve for x and write your answer in simplest form. So this time, I'm going to keep the fractions and simplify by distributing my negative here. So negative 3/2 x plus 1/2 minus 5. And I've got some like terms here and here. So negative 2x equals, that would be 2, so it would be negative 5/2, right? 2/2 minus 3/2. And then 1/2 minus 5 would be, let's see, that would be 2, that would be 10. 1 minus 10 would be 9/2. All right. Now I can certainly keep going, or maybe here I want to clear the fraction and multiply both sides by 2's. That would give me negative 4x equals negative 5x minus 9. See how nice that is? Add 5x to both sides, and I get x equals negative 9. That wasn't so bad. All right, let's move on to the next section. Justify solutions of an equation. All right, this one's a little bit tricky because it looks pretty simple here, but a whole bunch of other questions are going to pop up in a minute. So determine whether the equation below has one solution, no solutions, or an infinite number of solutions. Afterwards, determine two values of x that support your conclusion. So x is equal to x plus 3, and because my variables on both sides match, I have to make a decision based on my constants. So this one has a constant of 0, this one has a constant of 3, right, because it has no constant at all. So 0 and 3 are not the same number, so this is not true, or not possible, or, can't see it because it's off the screen, but I'm clicking on no solutions. And here's the rest of my questions. Now, this one is so easy it feels hard, but they just want you to prove that it doesn't work. So pick any number you want. A value for x that makes the equation false would be 5. Because when I plug in a 5, the left is 5, but the right is 8. What's another number that doesn't work? 0. If I plug in a 0, the left would be 0 and the right would be 3. So there's my proof that no number works. Submit your answer, and you're done. Let's take a look at another one. X minus 1 equals negative 9. So I'm going to solve this pretty quickly using inverse operations. Plus 1 plus 1, so x equals negative 8. So this has one solution. The value that makes this true is negative 8. I know that because negative 8 minus 1 is negative 9, and the right is also negative 9. Proof that only negative 8 works is by plugging in some other random number. I'm going to pick 0, because that's easy. If I plug in a 0 for x, the left side would be negative 1, the right side would be negative 9, and that would be false. And that's how you complete the third section, sorry. And then the last one, which we learned this week, is about absolute values. So absolute value is a distance in two directions. So that means you're going to have two separate equations. So the first thing I want you to focus on is making sure that there's no math outside of those absolute value bars, right? There's no coefficients out here. There's no constants out here. Because if there was, you'd have to move them over to the other side. So the absolute values and the quantity inside is the only thing that remains. Now, in order to remove the absolute value bars, I have to signify that there are two numbers that have a distance from 0 of 5. And that is the number 5 and the number -5. So this quantity I'm going to repeat, but notice my answers are one in each direction. So one positive answer, one negative answer. But the quantity inside the absolute value bar stays the same. Now I can solve both my questions. Subtract 3 using inverse operations. Again, using inverse operations for my coefficient. So my answers are -2/3 and +8/3. Positive. Two negatives make a positive. So -2/3 and +8/3. -2 fraction bar 3, arrow over, write a comma. There's my next answer, 8/3. So -2/3 and +8/3. And inserting the comma is what allows me to have multiple answers. Now notice these are braces, not parentheses. Parentheses represent an ordered pair, two variables. This is one single variable with multiple answers. All right, let's try that one more time, right? Making sure we have no math outside the parentheses. And then what we do is rewrite the problem 2 times. Again, write the problem 2 times, keeping the quantity inside the absolute value bars, right, the same, but writing the two values that have a distance of 15. That's +15 and -15. Use your inverse operations. To isolate your variable. And we've got y equals 2 or y equals -4. Y equals 2 or -4. So I type in a 2, a comma, and a -4. And that is how you complete homework number 3.